Hello everyone. In this session, I am going to explain about the gear pumps in fluid power system. Okay, in the fluid power system or in the hydraulics, you pump the fluid, which is the source of the working in the fluid power system and hydraulics. Okay, that the pumps what are there, those are already different types of the pumps in the previous sections. I have taken the classification. Now I am going to take the explanation about the gear pumps. Gear pumps means here the engaging and disengaging of the teeth of the gear, how the fluid will be supplied in the system. That I am going to discuss. The gear pumps I am going to discuss in this session, and remaining the vane pumps and piston pumps I am going to discuss in the further sessions. First we'll take that it's gear pumps means what? Gear pumps are less expensive but limited to low pressures. Gear pumps are supplying the low pressure and the cost is less. It is noisy in operation than either vane or piston pumps. Gear pumps are invariably of fixed displacement type. Means the fixed quantity of the fluid will be displaced by the gear pumps, which means that the amount of fluid displaced for each revolution of the drive shaft is theoretically constant. The constant fluid flow rate will be supplied by the gear pumps. The different types of gear pumps are external gear pump, internal gear pump, lobe pump, screw pump, and gerator pump. Okay, these pumps I am going to explain working one by one. First, I will take that is external gear pump. The external gear pump means here the gear teeth what are there, the two gear teeth which are engaging externally, the engaging or mating externally, and thereby fluid they are going to supply. Here the from this animation we'll come to know that clearly how the supply of the fluid by using the gear pump is taking place. That is the pumping of the fluid. Here this is the inlet. The fluid is entering here, and fluid will be carried around the pump where the space is found between the two gear teeths and the housing of the that pump. Okay, here the whatever the space found between the two gear teeths and also the housing of this pump, the fluid will be carried around this one. And during its rotation, during the action of the gear, whenever this gears will become this side, the fluid will become free. And the gear teeths are engaging here, those that will be pressurizes the fluid to come out from that the space. And due to that pressure, the oil or a fluid will be flowing in the outward. And like this, during the continuous operation of these two gears which are engaging externally, the, the suction of the fluid as well as the supply of the fluid in the hydraulic system or a fluid power system will be taking place. This can be explained, whatever this working is there, that can be explained by taking this the simple plane diagram that is here at the inlet. This is the inlet, the fluid is entering here and the fluid will be carried again, that will be explained here. These two teeths are subject to high pressure and tend to rotate gears in the direction of the arrows. In the direction of the arrows, there will be rotate. And second, the segment of two meshing teeth, the segment of the two meshing teeth, what is there? To oppose the rotation, intake intaking the and the making the net torque available a function of the one tooth. The torque will be available here to carry this one rotation. This engaging, the one is the driven gear and another one is a driving gear. That due to the torque, so both will rotate. The pressure between the teeth, the whatever the pressure between teeth in this segment pushes both ways. The pushes both the ways and does not affect the torque as the oil is carried around the outlet. The oil whatever is carried around the outlet here, the whatever the space formed and also the housing, that will not provide any subject to any torque. Okay, that will not affect any torque, that one. The same will be on other side also. This is pressure between the teeth in this segment pushes the both ways and does not affect the torque as oil is carried around to the outlet, and the oil is carried around this one and reaches at this point. And here what happens is when this will be, these two teeth will pushes the fluid and engaging here, the pressurizing will be taking place, that the fluid will be pressurized in the delivery line. These two teeth have only the tank line pressure opposing them. The tank line, whatever the pressure is there, that will be opposing this one. Okay, then those will be during the engaging, the pressurizing of the fluid in the delivery line taking place. Like this, by using the external gear pump, the whatever the fluid is there, that is sucked from the inlet and that will be delivered in the system. Next one, internal gear pump. The internal gear pump means the two gears whatever we are going to use, those are engaging internally engaging. Here this is the inlet, the fluid is coming here, and this is outlet, and this is the outside gear, and this is the inside gear, which are engaging internally. Those are engaging internally during its rotation. And here there is a offset is used for this one in order to carry the oil. Otherwise, the gears only rotate. There is no flow of the oil. And for that reason, the crescent is used here. The crescent means which will be make the offset of the internal gear from the external gear. Okay, that is outside gear from the inside gear. And here at this point, due to that upset only, the disengaging of the gear taking place between the inside and the outside gear. And due to the disengaging, the partial vacuum will be developed here. And due to that partial vacuum, the fluid will be enters here and that will be carried around the space of the outside gear, whatever is there. The outside, the external gear is there. Through that path or passage, the flow of the fluid will be taking place. And due to this eccentricity, at this point, again the engagement of the gate is taking place internally, and due to that, that will pressurize the fluid to flow in the delivery line. Okay, that due to that gears which are meeting or engaging internally, and due to that making the offset by using this crescent, okay, that makes the arrangement of the supply of the fluid in the delivery line. The same will be explained here. That is crescent is used here. Then this is the inlet, and due to the whatever the this disengaging of the gears, and that will forms the space or a vacuum here, and due to that oil will be carried in this direction. Okay, oil carried away by the both internal and external gears. Okay, here outside of this one crescent, also inside of the crescent, the oil will be carried around here. The same way here we can see. And this oil carried here, whenever the internal gear or a rotor, it will be there. And here, the whenever the engaging of the gear will be taking place due to that eccentricity, the outlet line through that one, the flow of the fluid will be taking place. And for that case and the internal gear, we are going to use. By using of this internal engagement of the gear, the pressure or a supply, pressurizing or a supply of the fluid will be taking place in the system. That is the internal gear pump. The next one is the lobe pump. Lobe pump is similar to that of the working of the external gear pump. The lobe pump working is similar to that of the external gear pump, but here instead of using the gear teeth, the lobes are used, and these lobes are very less numbers. You can see here these whatever the parts are there, this is called as a lobes, and these during their rotation, the lobes are engaged and disengaged. And here the similar to that of the external gear pump, here the space formed between the two lobes, the oil will be carried. Okay, here inlet of the fluid will be taking place, and the space whatever is there between the two lobes, the oil will be carried around, and that will be supplied in the delivery line. Okay, the Here, the space formation what is taking place between the two lobes as well as the casing of the pump, the oil will be carried around whenever the engagement of the two lobes again taking place, then that will pressurizes the oil in the delivery line. The same we can see here, the suction here will be taking place and that will be carried around the this pump and that will be discharges in the delivery line, and that is called as a vein also we can call, those are the lobes. Moving to next one, the screw pump. The screw means the two screws, the which are the two screws what are there, and during the its the screw movements what are there, the movement of the screw there, the space formed between the two screw flutes, the whatever the this screw flutes are there, between that space whatever formed, and along that one during the disengagement the inlet of the fluid will be taking place in this one, and during the screw movement the fluid will be carried, and whenever the engagement of the screw taking place with the another screw, that will be pressurizes the oil in the delivery line. Like this, by using the two screws, the oil will be carried from the inlet and that will be pressurized and supplied in the hydraulic system by using the engagement of the screw, and that is the screw pump. That is a screw pump, and here we can see that one, the two screws what are there, the one is a driven driving screw, another one a screw, another one is a driven screw. Okay, here the screw shafts we can see and the bodies which will be supporting for those screws during their rotation, and at the one point the inlet of the fluid is taking place, then that is carried around the screws, and whenever the screws are engages and that will be discharges in the outlet. Okay, moving to the next one. Last, that is a generator pump. The generator pump, whatever is there, it is similar to that of the internal gear pump. But here, only the eccentricity is used. The eccentricity of the this two internal and inside and outside of the generator pump we are going to use, not the crescent we are going to use here. It is similar to that of the internal gear pump. Here inlet is taking place and there the disengaging of this generator uh, teeths are taking place, and the generator teeth disengaging due to that one, the partial vacuum will be produced to suck the fluid from the inlet, and that will be carried around during its rotation. The space formed between the teeth of the generator pump and the whatever the outside generator uh, this teeths are there, and there it will be carried, and whenever the engagement of this one we can see here, the engagement of the generator teeth taking place internally, during that will be pressurizes the fluid to the outlet. Like this, engagement and disengagement of the teeth of the generator pump taking place internally, and during that time that is a fluid will be sucked and that is carried around during its operation, and that will be discharged in the delivery line, that will pressurizes the this fluid in the outlet line. Here we can see this is inlet and the pump shaft and generator pump, this one outlet, the inner generator and outer generator. Okay, this inner generator teeth we can see, and outer generator whatever is there, it is a internally whatever the teeth space will be formed and the housing of the that pump. Okay, this is the operation of the generator pump. Like this, in this one, these five types of the different gear pumps we have I have discussed, and the next we'll move that one. What are the advantages and disadvantages of this gear pumps? Okay, compared to the other pumps. Okay, we'll see next. Advantages of the gear pumps. We'll take first. They are self-priming. Here, the priming is not required. Initially, the supply of the water to fill the space, whatever is there, or the remove of the air, it will not be required. They give constant delivery for a given speed. For the particular speed, they are going to give that constant delivery of the fluid at the constant speed. They are compact and light in weight. The compact size as well as the weight is also less. Disadvantages of the gear pumps are the liquid to be pumped must be clean, otherwise it will be damage the pump. The liquid should be clean. Variable speed drives are required to change the delivery. Where at the constant speed, the fixed quantity of the fluid will be derived. If the variable, the flow rate of the fluid is required, we have to change the speed of the operation of the pump itself. If they run dry, parts can be damaged because the fluid to be pumped is used as a lubricant. These pumps should not be driven by dry. Okay, otherwise that will cause the damage because that will the friction will takes place between the gates because the fluid whatever we are going to use that is work as a lubricant during its operation. These are the different types of the advantages and disadvantages. And in the next class, I am going to discuss about the vane pumps, and also the further session I am going to discuss about the piston pumps also. Okay, and the performance of these pumps also I am going to discuss in the other sessions. Thanks for watching. If you like, share, subscribe, and comment.